Hi guys, Mrs. Brumwell here. This is the last part of 2.3. We're going to use what we know about finding derivative functions to solve them. And so we're going to solve some equations and inequalities involving derivatives. Okay, so this first part is asking me to find the derivative of this function. So we're just going to use our simple power rule to find p prime of x. Okay, so if I bring down my power and multiply by 2, I get 8. Drop my exponent by 1. Same thing here, 2 times 6 is 12, x to the first. This becomes 1 times 2, which is just 2, and then a constant is 0. So there is my derivative function. Now they're asking what is p prime of 2. So now I'm just going to substitute 2 in for x into my derivative function. So we have 8 times 2 cubed minus 12 times 2 plus 2. So here I got 64 minus 24 is 40 plus 2 is 42. So p prime of 2 is 42. Okay, now it says find the slope of the tangent line to the graph of p at this point. Okay, so remember the slope of the tangent line is the derivative. So we found this was the derivative function, but they want this particular point. So we're really going to find what is p prime of -1. So if I substitute in -1 into our p prime function, we've got 8 times -1 cubed minus 12 times -1 plus 2. Okay, and so if we simplify that, I'm going to get -8 plus 12 is -4 plus 2. Did I do that right? Sorry. -8 plus 12 plus 2. Maybe we got 6 there. All right, so that is our slope. So the slope of the tangent line is 6. Now they want an equation for the tangent line, so we're going to do y minus our y coordinate equals our slope we just found times x minus -1, should be x plus 1. Now they want the equation for the normal line to the graph of p at this point. So remember, normal means perpendicular. Perpendicular just means I'm going to use the same exact point, but I need the opposite reciprocal slope, which in this case would be -1/6. All right, example 2. Find the points on the graph of f where f has a horizontal tangent line. So remember, horizontal tangent line means our slope is 0 of the tangent line, and remember, slope of the tangent line is the derivative. So we want to find where f prime of x equals 0. So my derivative, I'm going to set it equal to 0, but my derivative, use my power rule, 3 times 4 is 12. X squared, 2 times 12 is 24, x to the first, constant disappears. So if I wanted to solve this, I'm going to factor if I can. I'm going to factor out my 12x. And then remember, once it's factored, I can set each factor equal to 0 using our zero product property. So I'm going to get x equals 0 or x equals 2. So that is where our graph has horizontal tangent lines. Okay, so they're asking this part, same function, where is f prime greater than 0, where is f prime less than 0? So how we're going to do this is we're actually going to look at some intervals and use our zeros as kind of boundary points. Okay, so we have everything less than 0 is going to be -infinity up to 0. That's going to be one interval. And then between our two zeros, 0 and 2, and then 2 on. So we're kind of using these zeros as like boundary points to separate our graph into some intervals. Okay, so we want to know what is happening to f prime of x. We just want to know, is it positive or is it negative? So I'm just going to pick some numbers to help us with this. So remember, here's our derivative function. We have p, or f in this case, sorry. So f prime of x is 12x times x minus 2, right? So if I want a number less than 0 in here, let's try like -1. So I'm just going to use -1. So we are finding what is f prime of -1, and I just care is it positive or negative. So if I were to plug in -1 here, I'd get negative 12 times negative 3, right? And negative times negative is positive. Okay, now I look at the interval from 0 to 2, so let's use 1. So let's find what would f prime of 1 be. So if I plug in 1 into this guy, I've got 12 times 1 minus 2 is negative 1, so I get a negative value there. Okay, now let's try between 2 and infinity, so I'm just going to pick 3 for an example. Okay, so I'd get 12 times 3, 36, 3 times 2, 1, so I get positive. Okay, so I'm positive on these two intervals and negative here. So we can say f prime of x is greater than 0 on negative infinity to 0, union 2 to infinity. And then it's negative, so f prime of x is less than 0 on the interval 0 to 2. All right, so again, we kind of used our zeros as the boundary points, and then we're just looking for positive or negative by plugging in some example values. All right, thanks for watching.